Moving on from 2.1, where we introduced what an equation of a line looks like, how to find the x-intercept and the y-intercept and any other point in order to be able to graph the line. Another really important feature of a line is the slope. The slope is the ratio of the vertical change, or rise, to the horizontal change, or run. So slope equals rise over run. So they can show you like different pitches. So this is, for example, the roof pitch chart. So if your rise is 4 over a run of 12, right, then you can see sort of the steepness of your roof. You can also do that with road grades. If it's an 8% grade, that means that it rises 8 feet over a run of 100 feet. So you can tell exactly how steep the road is ahead. To find the slope, you're going to find the slope given any 2 points on a line. You have an equation. It's the rise over the run, which means the change in y over the change in x. Change can be shown with the delta symbol. And then a change in y means you take one y value and subtract the other y value, divided by one x value, subtracting the other x value. So it's that change in x under the change in y. So I know we just briefly started objective 1, but we're going to skip to objective 5. And I know that I do this sometimes. I change the order the textbook teaches things in to suit the way that I like it. And the reason I've done this is that I really want to give you a purpose for rate of change before we do it kind of just like mindlessly over and over again. So the slope formula is applied to any 2 points on a given line, and it gives the average rate of change of y per unit change in x. So if I gave you an example, so this is the digital cable TV customers, it's the number of customers per year, and I said, what is the slope of this line? To find the slope, it's the change in y over the change in x. So we're going to look at what the change in y is. So we're going to look at from here, down to here. And so the y values go up to 47 and down to 37. So the change in y would be 47 minus 37. And this is over the change in x. So it goes from 2007 up to 2012. So you're going to do 2012 minus that 2007. If I plug this into a calculator, I get 10 divided by 5, which is 2. So I have a slope of 2, and the reason why I'm showing you this now is I want to talk about what that is. It's called the average rate of change. So it's the units that you can kind of figure out what it means. And so this is the 10 customers in 5 years, or over 5 years. And when you do 10 divided by 5, you get 2, which means that the rate of change is 2 customers per year. So once you figure out the slope of a linear equation, you can find the average rate of change, which is the amount that you're increasing or decreasing by per unit of usually time in a real world example. So for this one, the average rate of change for the following graph is that you have an increase of 2 customers per year. If you are taking a physics course or a chemistry course, kind of more Chem 60, you will be using this concept of slope and rate of change a lot. You use it in your labs. You use it to analyze graphs. So understanding that to find the rate of change, you look at the units, so customers. Oh, sorry, this is 2 million customers per year. Always look at that. So an increase of 2 million customers per year. But it's a really important thing to be able to interpret what a linear graph means and find that average rate of increase, or if your line goes down, that average rate of decrease. Okay, so we're going to switch back to probably objective 1, which is finding the equation of a line using 2 points. So now that you have a purpose for finding slope, now we're just going to do it over and over and over again. So there's 2 ways of finding slope. we're going to graph our points. We've got a point -3, 2, so left 3, up 2. We have a point 2, 5, so right 2 and up 5, and this is my line. If I want to find the slope, I have two choices. I can use the slope formula. And if you're using the slope formula, I didn't do this specifically for the one above on purpose, but what I like to do is I like to write my points on top of each other. And then its order matters. If I write this as 2 minus 5, so if I do this minus this, then I must do this minus this. So I would go -3 minus 2. 2 minus 5 is -3. -3 minus 2 is -5. So my slope is 3/5. If I did it with my points the other way around, if I went up, it would be 5 minus 2 over 2, take away -3, which would give me 3/5. I get the same slope. So it doesn't matter what point you make y2, x2, y2, and which point you make x1, y1, as long as the one that you subtract from is the one you subtract from when you're talking about x's and y's. So the next question is did this come out as a positive or a negative slope? So this is a positive slope. When you are graphing a positive slope, you can go up and right. So if I started at this point and went here, I could go up in a positive direction and right in a positive direction, just like what happened when I calculated the slope over here. Or I could go down, which is a negative direction, and left, which is a negative direction. So when you're graphing a positive slope, you have to go the same sign. So up and right, two positive directions, or down and left, two negative directions. But both of those will end up with a positive slope. A positive slope is one that is increasing from left to right. Okay, let's look at the next one. So slope, y2 minus y1, write your literal equation first. And then I like to put my points on top of each other. Okay, I could graph these. So you don't, if you're using this method, you don't need the graph. 3, -5. Okay, so the graph's just going to let us see the visual representation of this. Okay, but I'm going to go 3 minus -5. So I'm going to go 3 minus -5. So I'm going this way, which means I have to go -4 minus 3. 3 minus 5, or minus -5 is 8, because that's really 3 plus 5. And then -4 minus 3 is -7. So this is a negative slope. It is falling from left to right. If I had used my points the other way, I would have gotten -5 minus 3 over 3 minus -4, which would give me -8 over 7. So the reason that I'm showing this is that when you're graphing a negative slope, you have to have one positive direction and one negative direction. So this is a positive over a negative, which is the same as if it was a negative over a positive. Now what that means is that if I start at this point, to do a positive rise of 8 and then a negative run of 7 would give me that negative slope. Or I could do a negative rise of 8 and a positive run of 7. So we're going to be doing one of two things. Number one, finding the slope of a line. You can do that using the slope formula, or you can do that by counting. You could go from a point to another point. So if I go up 8 and left 7, I have a negative slope of -8/7. Or I could start here and go down 8 and right 7, and I still have that same slope of -8/7. In fact, when I answer my slope, I don't put the negative sign top or bottom. I put it out front, and that means that it could be on top or it can be on the bottom. It does not matter. All of those will graph this line. So to find the slope of a line, given 2 points, you can just plug them straight into the formula, or if you graph them, you can count and you can find the slope. These last two examples can be done the same way. So let's start off by using the slope formula. So we've got slope equals y2 minus y1 over x2 minus x1. And if we plug in our points, we've got -2, 3, and we've got 5, 3. If I go in this direction, I'm going to go 3 minus 3 for the y2 minus y1, and then I'm going to go -2 minus 5 for x2 minus x1. So 3 minus 3 is 0 over -2 minus 5 is -7. So we're introducing this concept of a 0 into our slope. So if you'll remember, 0 divided by anything is 0. So even if we did the points the other way, so if we were to reverse the direction and go this way, you would be doing 3 minus 3 still. And then you'd have 5 minus -2, which would still give you 0, but this time divided by +7. But it doesn't matter whether you're dividing by a positive or a negative, it's still 0. So what does that mean for a 0 slope? Well, if we were to graph these points, we have a point at -2, 3, and we have a point at 5, 3. If we were to connect these dots, you'll notice what we end up with is a horizontal line. If you remember from previous lessons, this horizontal line passes through the y-axis, so it would have an equation y equals 3. But in terms of slope, the important thing is that this is a horizontal line. Horizontal lines have a slope of 0. So if we look at the next one, we've got 1, -3 and 1, 4. And we're going to find the slope the same way. So again, y2 minus y1 over x2 minus x1. Sorry, I wrote a 2 there. So y2 minus y1 over x2 minus x1. Again, it's a good idea to write your points. You've got 1, -3 and 1, 4. You'll notice this time the x values are shared. So if we first of all go this way, we've got -3 minus 4 for the y values, and we've got 1 minus 1 for the x values. So this is going to leave us with -7 over 0. Or if we went the other way, again, it does not matter. You would have 4 take away -3 over 1 minus 1, which would end up with +7 over 0. But this time we're looking at having a rise over a run of 0. This, anytime you're dividing by 0, is called undefined. If we were to graph this, what does an undefined slope look like? Well, we've got a point at 1, -3, and we've got a point at 1, 4. If I connect those two dots, I have a vertical line passing through an x value of 1. The most important thing is that this is a vertical line, and vertical lines have a slope that's called undefined. So a slope of 0 has 0 rise over any run. So you can have a long run but no rise, and an undefined slope is any rise, like an infinite rise, but a 0 run. How to remember these? I always think of skiing. So if you are skiing or biking or whatever you tend to do on slopes, if you're on a flat line, right, you're safe. Your speed is 0. If you were on a vertical line, you are going to fall endlessly. In fact, your life is going to be undefined because you're going to fall forever. And that's how I remember the difference between a 0 slope and an undefined slope.